Today's lesson is 9.6, Factors of a Whole Number. Our learning target today is I can use multiplication facts to find the factors of a whole number. So, what is a factor? We can think about a factor in 3 different ways. The first way we can think about it is we can think of factors as whole numbers that can be multiplied to get a larger whole number. For example, 6 times 4 equals 24. 6 and 4 are both factors of 24. They can be multiplied together to get a larger whole number. I can also think about factors as the numbers of rows or columns in arrays. For example, when I think about the array work I did yesterday, the number 4 and 28 are factors of 112. They represent the number of rows and the number of columns I had in my array. The last way I can think about factors is this. They're the whole numbers that will divide a larger whole number without leaving a remainder. For example, 24 can be divided by 6 and it will get me a whole number of 4. I don't have a remainder because 6 and 4 both go into 24 evenly. 6 and 4 are both factors of 24. Let's try this work now. There are 15 bottles. Can those bottles fill cartons that hold 3 bottles each? Yes, they can. If I were to draw a visual, I could think of it this way. One carton holds 3 bottles. 2 cartons hold 6. 3 holds 9. 4 holds 12. And 5 cartons holds a total of 15 bottles. So looking at that, 3 times 5 equals 15. 3 and 5 are both factors of 15. Can 15 bottles fill cartons that hold 4 bottles each? No, they can't. When I try the same counting up strategy, 4 does not go into 15 evenly. So notice, I'm going to try it. So 4, my second carton would give me 8. My third carton would give me 12. But if I try to fill another carton, it's not going to work. If I make another carton with 4 more in it, that's going to give me 16 bottles. And that's 1 too many. So 4 is not a factor of 15. It doesn't go into it evenly. What other sizes of cartons could you use to fit those 15 bottles? Discuss this now. Pause video. Great ideas. We could have 1 carton with all 15 bottles in it. We could have 3 cartons that hold 5 bottles each. Or we could have 15 cartons that hold 1 bottle each. So 1, 3, 5, and 15 are all factors of 15. They go into that number evenly without a remainder. When I write the factors of 15 all in a row, I notice a pattern. I notice that 1 times 15 equals 15, and 3 times 5 equals 15. So I'm noticing right there some factor pairs working their way towards the center. I wonder if we'll notice the same pattern with 16. On your slate, try to figure out what those factors will be. Pause video now. Great work. Notice when I write the factors for 16 in order, I go from the smallest factor all the way to the largest factor. I'm also noticing that it follows that same pattern. So 1 and 16 are a factor pair. 2 times 8 is a factor pair. And I'm left with 4 in the center. 4 times 4 equals 16. It's a factor pair to itself. On your whiteboards, try to identify the factors from the numbers 17, 18, 19, and 20. So I should see you writing the number on one side of your board and listing the factors on the other side. Do this now. Take a look. Do your factors pairs match mine? Looking at these numbers and their factors, which numbers have exactly 2 factors? Correct. 17 and 19. These are both prime numbers. Their only factors are 1 and themselves. Which numbers have 2 as a factor? When I look at these factors, I'm seeing 2 for the numbers 16, 18, and 20. I'm noticing that these are all even numbers. So 2 is a factor of even numbers. Which numbers have the most factors? I can tell by looking that 18 and 20 have the most factors. They each have 6 factors. Which numbers have an even number of factors? Well, 15, 17, 18, 19, and 20 all have an even number of factors. 16 is the only number with an odd number of factors. It has 5 factors. And when I look at those factor pairs, 4 is a special number. It's a square number. 4 times 4 equals 16. If I turn that into an array, it would make a perfect square. Which numbers have 1 as a factor? You're right, all of them do. In fact, every number has 1 as its factor. You might notice that each of these numbers not only has 1 as a factor, but it also has itself as a factor. No matter the number, 1 and the whole number, which is itself, will always be a factor pair. So to review, factors are smaller numbers that can be combined to make a larger number. Or in the reverse, if I was going to divide, I could break this larger number up into 2 smaller numbers, or factors. So in this case, 2 and 3 are both factors of 6. You're going to have a chance to practice this now. You're going to be turning to page 219 in your math journal. And we're going to be playing Factor Bingo today. Your first job is going to be to take these numbers on the bottom of the page and to fill them into the chart up here. You may notice there's not enough boxes for all of these numbers. You're going to try to pick which numbers you think will have the most factors and fill them in randomly in the chart. One strategy you might have is to cross them off as you go. So I'm going to take a guess, and I'm thinking that 35 might have a lot of factors. So I'm going to fill it in somewhere on my charts, and I'm going to cross it out. I'm going to take a guess, and I'm thinking 58 might have a lot of factors. So I'm going to pick it and fill it into my chart. I'm going to guess 11 has some factors. I'm going to pick it, fill it into my chart. So notice I'm picking numbers that I think might have a lot of factors, and I'm filling them in randomly. I'm not just copying them right from the numbers on the bottom into my chart. Once that's done, you're going to follow the directions in your student's reference book on page 285 and 286. This will tell you how to play the game. Your teacher may model how to play also, so pay attention. Have fun!